Hey guys, in this video we're going to be solving this following problem about logistic regression. For this problem, I'm going to assume you know the logistic regression objective, which we call the average logistic error. If you guys don't know about it or you want more information on it, I would suggest looking at the lectures, or you can take a look at the video I created for the DS 4400's midterm exam, where I go into more detail about the derivation of that objective. With that in mind, I'm going to write out our objective. So we say our logistic objective is L of x is equal to, actually, assuming we have a prediction in mind, which we do in this case, I'm just going to write out our simplified objective, which is 1 over n times the sum of I to n of yi, so this is the ith label, log of y hat of I, which is the ith prediction. So I'm going to write this in parentheses. It's actually the negative in the front. I forgot about that. And this is plus 1 minus y hat, y of I, log 1 minus y hat of I. So this objective is called the average logistic regression error. Because it's an average, we see this part right here is telling us this is an average. But if we look at this main component right here, the reason why this is an error is, well, if we say if y of I is 1, right, because our labels are going to be either zeros or ones, and y hat of I doesn't agree, well, so if y of I is 1, so that means this term over here, let me write it out. So if y of I is equal to 1, so that means we're going to look at this term. Well, this term is going to get zeroed out, right? Because 1 minus y of I, well, that's 0. So we don't even really care about this term, assuming y of I is equal to 1. So if y of I is equal to 1 and our y hat prediction is really close to 1, well, we know log of 1 is 0, right? So in that case, if y of I agrees with y hat of I, then our error is basically 0. However, if y hat of I doesn't agree and is actually some value more close to 0, well, if you look at the log curve, right, if you have, x and y, and you have the logarithm curve, well, it looks something like that as you get close to 0. So this is going to be a really big negative number. So our error is going to be a really big positive number, right, because we have this negative right here. Conversely, so let me get rid of all this. Conversely, if y of I is equal to 0, well, this term's going to get zeroed out, right? So we're not going to care about this because, 0 times anything is 0. And this term right here is going to be 1, so we're going to basically take the full magnitude of log of 1 minus y of I. So remember, again, if y of I is really big, we're going to say 1 minus something really close to 1, and that's going to give us a really big negative number. But if y of I is small, right, something really close to 0, then we're just basically taking the log of 1, which once again is 0. So what this objective tries to illustrate is how much y of I agrees with the prediction y hat of I. Okay, so now that we have our objective, which I'm going to reiterate one more time, this is the logistic regression objective, and what the objective measures is the average, that's this term right here, logistic error, which is this term right here. Right, and if you remember, our logistic error is our cross entropy between our labels and our predictions. Okay, so this question asks us to calculate the error for a single sample. So right off the bat, we get n is equal to 1, which means we can just get rid of this whole mean term. You can also get rid of all these i's, so I'm going to do that real quick. So these i's all becomes 1 because we just have one sample. And then I'm going to move this equation right here. Okay, So we also get information about the single sample. And so it seems that our true labels are one-hot encoded. So what I mean by that is, well, based on this information right here, it seems, well, y of 1 is equal to 1. And then based on this information up here, we get, well, y1 hat is equal to 0.8. Sweet. Conversely, if our labels look something like this, so our true label looked more like this, well, so I'm just going to write it all out. So if our true label like this and our predictions look like this, well, this would tell us that y1 is equal to 0 and y1 hat is equal to 0.2. But we know that's not the case for this problem. Okay, so now that we have our y1 and y1 hat values, we can plug it into our equation. So we get negative 1 log 0.8 plus 1 minus 1 log 1 minus 0.8. And if we simplify that out, that becomes negative log of 0.8 plus 0 log 0.2. And if we simplify it one more step, we just get negative log 0.8. And that's our answer. So our error is equal to negative log 0.8. Sweet, thank you.